Hi, in this video, we're going to see how we can model, analyze, and design one of the most efficient bridge systems in India. More than 70% of small and medium span bridges are built using this system, the reinforced concrete T-beam and slab bridge. In CSiBridge, we'll go to File and click on New. We'll select the units and the materials for our projects. We'll stick with kilonewton per meter and we'll select India for our materials. Now CSiBridge offers you various templates. We have quick bridge, segmental, suspension, cable state and many more. For our requirement, we'll go with the quick bridge. Now in front of you on the screen is a quick general bridge template. You will input all the values here and the program will generate the model for you. We'll start with the layout. This is the definition of the layout line which we'll have, and the bridge will be modeled along the layout line. We can define the starting station, grade, skew if any. Then we can define the initial location of the bearing as well if we have as per our project. We can define the radius or if there is any super elevation. Now defining span lengths, 20 semicolon 20 just means two spans of 20 meter each. To add another span, we'll just simply add another semicolon followed by the length of the span, keeping them same 20 meter each. Next comes the superstructure data. There are variety of options available. We'll select the concrete T-beam, which is our requirement. If we'll click on edit section, we can see the section properties, slab material property, girder material property, number of interior girders. These can be changed later as well. We'll stick with the default values. We'll press OK. Then next comes the substructure data, which are abutments and bends. We have selected a new typical abutment and new typical bend. We can edit both of them by just simply clicking on edit. Abutment type, we have three options: ground, continuous beam, and then you can also select none. We'll stick with the ground, and foundation we'll stay with fixed. Again, you can change as per your own convenience. Then for the bends, we can edit the bends as well. On the bends, what type of bearing do we want? Do we want single or do we want discontinuous? Then we have the cap beam option. You can always select for a no cap beam if you don't want any cap beam on your bend. We'll stick with the default values. Columns, rectangular column, circular column, don't want any columns just for the analytical purposes. Foundation, fixed, pin, spring, none, again up to you. We'll stick with basic. Then next comes the live load, vehicle library. We'll simply go to the drop down menu and select IRC India for our vehicle library. Then we'll click on live load vehicle, show vehicles for live load. You can see the whole library has been loaded. We'll simply select whichever we require, or you can simply add all of them. All of them have been added. Then you have the typical lane width, 3.65 meter. Then you have the analysis and design options, load cases. You can ask the program to generate the wind load cases for you. Then you have the design option. Then we select the bridge design code, IRC 2020. And then the next option is design requests. You can ask the program to generate the design request for you, or you can generate them later. We'll generate them later. We can still change the units, and we can change the units at any time during modeling or while viewing results. We'll press OK. And now the program will generate the bridge for us. It will assemble all the data that was input by us, and it has assembled the bridge for us. We can see the extruded view of the bridge by going here, set display options, general options, select extrude, press apply. You can see the extruded view of the bridge. Now let's look at the different menus that CSiBridge offers once we are done with the modeling. Now first we have the home. Under the home you have four sub menus: view, snap, select and display. Under the view you have the options to zoom in, zoom out. You can rotate the bridge. Then you have the snap options. If you'll hover over the snap options, you can see what they mean. You can check and uncheck as per your own convenience. Then you have select and deselect options, where you can select the properties or any object. And then you have the display options. The first one is enabled, which is the show on deformed shape. Then the next one is the show bridge superstructure forces, then the deformed shape, and then so on. Then next it offers is the layout. Now the layout line is the one which we defined. Now bridge models around the layout line. So if we'll go and modify the layout line, we'll see the definition of the layout line. We have the station, bearing, radius, grade, all the information about it. On the right, we have the coordinates of the initial station, can be changed right now. Then we have the initial and end station data. You can specify the location of the initial bearing as per your project. Then you have the horizontal and the vertical layout data. So if there are any horizontal curves in the layout line, or if there are any horizontal curves in your bridge, we'll define those curves in the layout line, and the CSiBridge will automatically model the bridge around it. There are some quick start templates to go about. For example, we can select this template: straight, curve right, and straight. We'll simply select this, press OK. Program will automatically generate that for us. You can edit these values. Then you have various options and define a curve of your own as well. We will see how this affects the modeling part. We'll simply click OK. Then we'll come to the vertical layout data. Same procedure. There are some quick start templates. You can select any one of them if these suits your project properties. For example, we'll go with straight parabola up straight. You can see the program has generated that for you. We'll press OK. Now you can see we have both the horizontal layout and a vertical layout definition. We'll press OK. You can see the curved layout is there along with the vertical one. Next, in the layout, you have the lanes. This is the lane which we defined. It starts from 0 meter, ends at 60 meter. There is no vertical offset, and the width of the lane is 10.218 meter. We'll stick with this. We'll press OK. Then the next we have the components in this. Under the components, there are three parts. First part is where you define the material properties, frame properties, cable properties, tendon properties, link properties, and rebar. Under the material properties, we can see all the materials that have been defined. To define a new material, we'll just simply click on this. We'll select our region, material type, concrete for M60. We'll press OK. You can see the material has been defined. You can check the properties from this button. We'll press OK. Then we have the frame properties. These are all the frame properties that have been defined by the software for us, and these are the properties that are being used in the model. For example, bent beam. We can see the properties of the bent beam. Then we have the bent column. We can see the properties of the column. And if you want to define a section, we can simply define it from here. You can choose a section you want to define. You can choose a section property as well first. Next, under the components, we have the superstructure and substructure. First, with the superstructure, program offers you 5 different menus in superstructure. We have the definition of the deck section first. This is the deck section we defined during the first stages of the modeling. We have the bridge section name. We have the slab material property, and we have the girder material property. We can change them to M60 as per our convenience. Then we have number of interior girders 2, 1 and 2. And then the other properties as well can be edited as per your own convenience. Then if we'll click on the loads, you can see these are the loads that are being applied by the software for us. Again, you can edit these loads as per your own convenience. Barrier load, second barrier, sidewalk load, live load on the curb locations, bearing surface loads, and the temperature loads. We can also see the load patterns that have been defined for us: dead, haunch, barrier, sidewalk, temperature, wind structure, and wind live load. We can also check out the properties for the wind structure load by clicking on modify lateral load pattern, and then you can check out the properties and edit them as per your own convenience. Same goes for wind LL, modify show lateral load pattern, and can be edited. We'll press OK, OK, and come back to the model. Then next comes the diaphragms. You can see program has defined a diaphragm for us. We'll see the properties. Diaphragm name can be edited. Diaphragm type, you have 4 options: solid, cord brace, single beam, steel plate. Closure is only for the concrete precast, I girder, precast, box girder, and super T bridges only. Then you can define the diaphragm parameters: thickness, diaphragm depth, and you can ask the program to use the girder depth except solid girder bridge sections. We can change the diaphragm material from here. We'll press OK. Next we have splices. Then next is parametric variations. You can see there aren't any parametric variations. You can simply define a new one by clicking here, and then you have variety of options available. You can also click on quick start, and you can select one of these templates to start your parametric variation. We'll press OK. Next we have substructures. Under the substructures, you can see we have 5 options: bearings, restrainers, foundations, abutments, and bend definitions. First we'll see the bearings. You can see program has defined bearings for us, pin fixed. We'll see modify properties, and you can see this is how it looks. Then we have restrainers. There aren't any defined. You can define one by simply clicking here. Next we have the foundations. We are not modeling the foundation as well. Again, you can define a foundation from here, spring or advance. You can see under the advance, program offers you various options: isolated footing, combined footing, pile group, pile pier, and pile shaft. And then we have the definition of abutments. This is the one abutment which have been defined for us. We'll click on modify show properties. These are the properties of the abutment. Connect to girder bottom only. Support type is foundation spring. Then we have the foundation spring as fixed. We'll stick with the default values. Then we have the definition of bends. Again, we'll check out the bends that have been defined for us. Cap beam section have been defined as bend beam. Cap beam length is 10 meter. Support type for the bend is column. We can click here to check out the column data. Section of the column is bent col. Distance of the column is here. Then the height of the column and foundation. These can be edited as well. You can change the number of columns from here. Then you have the bend type, single bearing line, double bearing line with closure pore, and the double bearing line. And then you have the superstructure connection, connect to the girder bottom only. You can change that to connected to girder top and both bottom as well. We'll press OK. Next we have loads. Under the loads, first we have the vehicles. Under the vehicle, we have either vehicles as individuals. These are the vehicles available. And then we have the vehicle classes. You can define a new class and add the vehicle there. If you want, I can simply add IRC-A and IRC-70R in a vehicle class data, vehicle class 2, and press OK. That class has been created. Then we have the dead load patterns, which we just checked out. Again, same. Then we have the response spectrum for seismic design. And then we have the load distributions for point load, line load, and area load. Then next comes the bridge tab, which is one of the most important tab in the software. So bridge tab contains the bridge object, which is named as BOBJ1, which means bridge object 1. This contains all information about your bridge. We'll click on modify to check out the properties. You can see we have the properties for the span first, span 1, start, length, end station, support, and the end support. Then we have the properties for span 2 and span 3. And this is how our bridge looks. And this is facing north. You can click on show enlarge sketch to see a big sketch. And then on the bottom right, you have modify show assignments. These are all the assignments that have been defined in the bridge. Any changes made here will automatically be made in the model by the program. First one, we have the spans. We'll click on modify show. Then we have 3 spans, span 1, span 2, span 3, what section that span is using, and if the section varies. We can click on modify show section variation along selected span. You can see span 1, section property B section 1. And if there is any parametric variation, we can simply select from this drop down menu. We can do the same for span 2 and span 3. Then next we have the user discretization points. If you want to define any points on the bridge, you can define them from here. Then we have the abutments of the bridge. These are the abutment assignments. First we have the start abutment, name, abutment direction, diaphragm property, diaphragm offset location. Then we have the substructure assignment for the start abutment. Abutment property we have used BABT1. Then we have the substructure location, elevation, horizontal offset if any, and then finally we have the bearing assignment. And then we have the properties for the end abutment as well, starting with the superstructure assignment, then substructure assignment, substructure location, and the bearing assignment. Then we have the bends. These are the bent assignments. You can see bent is at the end of this span. We are checking out the properties for the span 1. We can simply from the drop down menu select span 2 and check out the bend properties as well and make any changes if required. Then we have the in-span hinges. You can define here if you wish. Then we have the in-span cross diaphragms. These are the diaphragms defined by the program for us. It means on the span 1, diaphragm property DIAPH have been used, all spaces. Bearing have been used default. and the distance at which the diaphragm is 5 meter from the starting of the span 1. Reference line is layout line. You can see these pink lines are the diaphragms. Then we have the in-span splices. We can define if we have any. Then we have the super elevation. We can introduce if we have any. Then the next is the tendons. We can define our tendons here by simply clicking on add new tendon, and we can define the tendon profile and tendon properties from this menu. Then we have the girder rebar, stage construction groups. Stage construction groups are the bridge object groups. You can see we have 4 groups defined: span 1, span 2, span 3, super bird, diaphragm. We can add a new bridge group. To add a new bridge group, we can define the bridge name. Then we can define the bridge group type. There are various options: section, top slab, web, diaphragm, cross frame, support structure, bearing, mix. If you'll click on mix, you can select what all you want to include in that distance. We'll stick with the section. We want to define entire section. Start span will be span 1, span distance from the 0. End span will also be span 1, and end distance will keep 5. This means first 5 meters of the bridge have been added to this group called BGRP1. We'll press OK. You can see that this has been defined. We'll again press OK. Then we have the point load assignments. There aren't any, but you can define them here. Then we have the line load assignments. Line load assignments is the lane load, and then we have the wind load here as well. Then next we have the area load. For the area load, we have the dead weight, and then we have the concrete pour permanent. Then we have the temperature load assignments. Again, can be changed as per your convenience. Then we have the wind load assigns and slab bed concrete load assigns, all which can be edited. Once we are done with the editing, we can simply click OK. Program will recognize if there are any changes. It will recreate the model for you and present it to you. We'll come back to the bridge. You can see under the bridge there are some shortcuts as well. You can directly go to the abutments from here. You can directly go to the super elevation from here, and so on. Then next comes the option for the update. It means if you want to update the bridge. Since we have selected auto update bridge, so every time we change something, bridge automatically updates. We can also manually update it. We need to select the bridge object. This is the bridge object we have. And then the action which we want the program to take, discretization information, and then we have the structural model options with us. You can update it as a spine model using frame objects. You can update it as an area object model, and you can also update as a solid object model. If we click on solid object model, we can then go back to update, select update as spine model using frame objects, press OK, and you can see program has made a spine model for you. We'll go back and keep editing as a area object model. We can also specify the preferred submesh size. We'll press OK. The model is ready now. Now we'll come to the analysis part. Under the analysis part, we have first the load cases. We can simply click on this small arrow here to see all the load cases that are available with us. We have the dead load, which is the linear static. Then we have the modal. Then we have the moving load. We can click on modify show load case. You can see it is using the vehicle class 1. We can change that vehicle class 1 to vehicle class 2, which we selected. Or we can also select a single vehicle as well. We can select IRC-A for our analysis, click on modify, and it has been modified. You can specify the directional factors: vertical, braking acceleration, and centrifugal if any. Load case type is moving load. We'll press OK. Then we have the barrier, sidewalk, wind S, and wind live load. We'll press OK. You can define a new load case, and you can select the definition of the new load case from here: static, stage construction, multi-step static, modal, response spectrum, time history, moving load, buckling, steady state, power spectral density, and hyperstatic. Then we'll go to the analyze option. Under the analyze, we'll click on run analysis. We'll check and uncheck all the load cases we want to run. We'll stick with all of them, and we'll click on run now. Now once the analysis is complete, we'll come back to the model and we can see the deformed shape If you will hover the mouse at every point, you can see the displacement for the respective points U1, U2, U3, R1, R2 and R3. Now under the home, we'll come here, which is show bridge stresses. On your screen, you can see the bridge object response display. First, we have the display component, which is the result type. You have various options: force, stress, displacement. Then we have the results for, you can see the results for the entire bridge section or for interior girders or exterior girder. Then what type of response you're looking for: axial force, you can check that; shear vertical, you can check that as well. And then next comes the case and the combo. You can select the case or the combination for which you want to see the results. We can check out the results for the moving load by simply clicking on move 1, and the program will display you the results. You can change the units at any time during this simply by choosing the desired units of your own, and it will get reflected. We'll click on done, and then we'll come to the next part, which is the show deformed shape. Now you can check out the deformed shape for various cases and combinations as well. Then you have the multi-valued options. If there is a multi-step static, you can select the step number as well. Then we have the scaling. We have kept it automatic. If we'll click on user defined, we can define it ourselves as well. If we'll select 1, then you can see the true deflected shape of your bridge. We'll click on apply, and you can see the true deflected shape. If we'll hover over at any point, we can see that deflection is almost 0. Next, if we want to check the forces for our columns and bent beams, we'll simply come here, we'll click here, we'll select the case or the combination we want to check. Then we'll select the display type of force or stress. The component, we can select axial force, and then click on apply. And you can see it displays you the axial force in the columns and in the bent beam. You can also click here, fill diagram with contours or show values. If we'll click on show values, it will display the values as well. We'll press OK. And we can click here to see the undeformed shape of our bridge. Next, we'll come to the design part. Then under the design tab, we first have the load combination. You can see the program has defined some load combination for us. We can check out the load combination. We can edit them, or we can add new by clicking on add defaults. Then the program will ask for the design type for load combination, which is the bridge design. Then click on set load combination data, and then check or uncheck whichever limit state you want to check for. We'll check for strength for basic and accidental, and for the serviceability, we'll check for rare and frequent. Then you can add or remove the load case if you want to from here. We'll click on OK, and then finally click on OK. And then we'll come back here to check out the load combinations. You can see these are the load combination created by the program for us. Strength basic group 1, under which there are combinations for the strength basic. Then there is a strength accidental group. Then there is a service rare group. And then finally service frequency group. We'll press OK. Then we'll come to the design requests. We'll click on design request and then click on add new request. Now under the request, you have few options available to define the request. First one being the bridge object. Then you have the check type. We have 3 options. We can check for stress, shear and flexure. We'll define for flexure. We can change the name to flexure, so it is easy for us to identify. Then you have the location, and then you have the demand set. It is the name of the set, you can edit it. And then it is the combination for which you want to check. We'll select the strength basic group. And next, it is the live load distribution to girders. There are 3 methods. First is the use factors defined by the user. Then you can ask the program to directly girder forces from the analysis. We'll press OK. And you can see the request for the flexure has been created. We'll click on add copy of request. Under this, we'll name this as shear. And then we'll select this concrete T-beam shear. We'll keep the combination same. Press OK. And the last we'll create for stress. We'll change the name to stress. Now for the stress, we'll change the combination to service rare, and we'll press OK. You can see 3 design requests has been created. One for flexure, one for shear and one for stress. We'll press OK. And now we'll click on run design and then click on design now. Now once the design is complete, the program will automatically display the bridge object response again. And now the result type you can see has been changed to design/rating. results for left exterior girder, or you can simply select all girders. Then you have the response type, which has been selected as moment. Then you can also select it as required bottom rebar area to resist the moment in positive direction. This will display the rebar area for you. If we will change the units to kilonewton per mm, you can see the rebar area required. You can also select it as top rebar. It will show you the top rebar. And the request that we have selected for is the D request one for flexure. We can similarly view the results for shear. We can select the response for the shear. We can either select the controlling demand capacity ratio. We can select the shear rebar area length, or we can select the longitudinal rebar area for the bottom slab or the longitudinal rebar area for the top slab. Then the last one, we have the stress. For stress, again, we have different response options: controlling demand capacity ratio, shear rebar area length, then the longitudinal rebar area and the longitudinal rebar area for the top slab. And this is how you view results for the design of the T-beam/concrete bridge.